Six is Edio out from California. I'm here going to talk about CP6, which got launched a little more than 2 months ago. And I had some other thoughts about CP6. Here's just an outline of the presentation. I'm going to talk a little bit about the other satellites that we've built at PolySat. Talk about CP6, the NRL Payload that got added from CP3 to CP6, and also the CPX Data Decoder, which some of you have probably played around with and have helped us out download more data from CP6. So PolySat is a project at Cal Poly State University in San Luis Obispo, which I graduated there last year in June. And I'm still quasi-involved with everybody down there, so I kind of know what's going on. I helped work on CP6 a little bit in the beginning stages, but it got integrated after I graduated, so I didn't get to play around with the final version. This is CP1, which was built back in 2000, 2001 timeframe. It had an Alinco DJ-C7. Actually, two of them. Those are the old school credit card transceivers. But they took the case off, and it actually used a DTMF kind of format to download the data. So that was actually kind of cool. You could hear the satellite sing to you in the lab. And it had a sun sensor that sat right inside the hole here on the top. And unfortunately, it was lost in the Dnepr 1 launch failure in 2005 or something like that, 2006. So after CP1, we completely redesigned everything and built CP2, which had an energy dissipation experiment on it. And unfortunately, it was also lost in the Dnepr 1 launch failure. But we had a flight spare, and so we reflew it as CP4 on the Dnepr 2 launch, and that was successful on April 17, 2007. And right now, it's pretty much brain dead. You can get into the radio, and the radio says, "Hey, I'm here," but there's no the command and data handling PIC processor is not there at all. Probably due to I2C issues, because we had a bunch of I2C issues on that spacecraft, and all that stuff was fixed for CP3, which was also launched on that same launch in 2007. We did notice that the receiver is a little bit deaf, and it had a camera experiment on board, but because of the receiver issues and also some other payload issues, we never actually took a picture from it. So we had a flight spare and decided to refly that again as CP6. You notice there's kind of a theme going on here. Always build two, because you'll probably fly the second one. Hint, hint, Graham. So CP6 was flown earlier in the end of June this year. My senior project was to fix the receiver with adding an LNA and filters and some other tricks to help improve the receive sensitivity of the receiver. We've successfully taken pictures with it, which we're still downloading right now. And there's also a plasma experiment from the Naval Research Lab that we added on board, which I'll talk about later, a little bit more later. As I said before, it's a refly of CP3. Flight spares. We had some minor bus software upgrades, but besides the software and the low noise amplifier, we really didn't change the spacecraft at all in between CP3 and CP6. Standard 1200 baud FSK, AX25 in the UHF bands, pretty standard stuff. The orbit's not really all that standard. It's at 420 kilometers at 42 degrees. So at Cal Poly in the Bay Area in California, we're pretty much at the north pole of the orbit, which is kind of interesting. It's cool because CP2 and CP3 were polar orbits, and so they come by every day at 10 p.m. and 10 a.m. They're flying over. But CP6 is shifting and moving in odd times of the day. Currently, it's doing fine. Camera's working, and we're downloading pictures. The health is fine. Batteries are looking good. So we're really excited. There's a picture of the launch. It was launched from on a Minotaur out of Wallops Island in Virginia. And here's the other two satellites that were on the P-pod. This is AeroCube 3 from the Aerospace Corporation in Los Angeles. It had a bunch of cameras on it too, and that's just a continuation of their AeroCube project. And then the one on the right there is HawkSat-1, which had some sort of experiment on board. Not sure if it's working at all. AeroCube 1 works and CP6 works, but we haven't had any contact with any of the people at the Hawk Institute of Space Sciences, which built HawkSat-1. So we don't know if it works or not, unfortunately. And then CP6 is there in the middle. So the NRL Payload was a plasma experiment. Was looking at measuring electrons flowing in the plasma between these two tungsten filaments, which are out at the end of these kind of booms, which they're just like rolled up tape measure that pop out, and out at the end there's these tungsten filaments that you can charge up, pass a lot of current through them and high voltage, and they emit electrons, and then we can measure the electron flow from the ends of the tapes to the electron collector steel tape, which is 1.1 meters long. So these deployables are really long, and we're not quite sure what they're going to do to the antennas, detuning them and all that stuff and messing with the patterns. It hasn't been deployed yet, but it will get deployed the next month or two or something like that. The interesting thing about this payload is that since we didn't modify the CP3 bus at all, really, to go to CP6, this entire payload just kind of fits over in unused space in CP3, which was actually about a quarter of our spacecraft, with some cutouts for the cameras. So there's a camera board with the two cameras that point up, and then the NRL payload just kind of sank down in between the two cameras. So it was kind of a logistical nightmare. Really small space with high voltages right next to low voltage cameras and CMOS stuff and stuff like that. But we got it working. I think some pictures. Yeah. So here's the top. Oh, it's kind of dark. But here's CP6 right here, and then this is the payload face, and there are the two cutouts for the cameras. And then this is on the underside of this door right here, which pops out, are the three steel tapes that have the tungsten filaments on the end and the electron collector. There's a picture during fit check or something like that. There's a picture of the inside of the payload. Here's the steel tapes, the two emitter and then the collector steel tapes rolled up with just some fishing wire. And then on the outside, can't really see it, but it's just a standard nichrome burner right here that the fishing line passes through, and then you just give it command, and when the doors open, it'll pop out the tapes. And yeah, there's only one board with all the high voltage and the measurements and all that stuff on in the interface with the CP6 bus. So yeah, so that's pretty much the satellite. We also developed the CPX Data Decoder program to help increase our data downlinked from CP6. We were going to use GENSO, but it wasn't quite ready, so we had to think of something quick. So Dave actually wrote the program. It's written in Ruby, PHP, and MySQL on the server side, and it's a Python program on the client side, which you load up onto your PC in your shack, and it just listens on a COM port for TNC data and displays that data in nice format, and then also sends it to a server at Poly so that we can get it. There's the website. There's the website again. I took this screenshot earlier this morning, and you can see it's all the Japanese. So CP6 was flying over Japan at that time. So they've actually been really active in tracking CP6, which has been pretty cool. There you go. Speaking of where people are, yeah, there's 4 maps of where people are. Bunch in Japan. There's Colin down here, way down here in New Zealand, and then America and around Europe. This is the data that we've downloaded as of probably 2-3 weeks ago. 358K from the SRI station, which is where I work now. And these top couple are Cal Poly people. I'm not sure why they aren't using a single username, but whatever. In total, we've gotten down about 2.5 megabytes of data so far, which is pretty good. If you looked, last year I presented on CP6 and also on the comm paper I was writing at the time, and 2.5 megs is getting up there in terms of data down from CubeSats. So it's been very positive to get more data down. So that's the top, and then more people that have helped out. Kind of looking at the list, I'm like, why are some people getting so much more data than other people? And so I decided to write a survey, and I emailed it out to just the registered users of the MoreDB's program. And I've gotten 14 responses so far. I'm not a pollster, I'm not a survey guy, so I just kind of wrote some stuff up, and it's probably not correct, but here are the results anyway. I asked about Doppler tuning. 65% of the people were doing completely automatic Doppler tuning with the computer program. 15% were actually doing it manually, so they were sitting there in front of their radio every pass, manually tuning it. And then 20% were doing automatic with fine adjustments. CP6, the two transceivers on CP6 are about 600 hertz apart. And so when they switch comms every 5 minutes, you get this 600 hertz jump. And you're not sure, when it comes up over the horizon, which comm it's going to be on. So that's one of the issues with CP6. So manual tuning is sometimes necessary. And the antennas, a lot of people are using the high gain with azimuth elevation rotors. But the 20% on there, a couple people are actually using omnis and directionals just pointed in a direction. And they got data too, so you don't have to have a big antenna or rotors or any of that stuff to collect data. This is just about what radios you're using. A lot of people are using ICOM 910s, some Yaesus, Kenwood TS2000, pretty standard stuff, and then some of the older ICOM radios. The question is, if you're using an azimuth elevation rotor, what kind are you using? A lot of people are using the Yaesu G5500. It's pretty standard. And then there was some other Yaesus and down there. Kind of interesting. TNCs. What kind of TNCs are you using? A lot of people are using MixW and AGWP, which are software TNCs. And actually, Colin down in Australia had a little experiment where he had a radio, and then he split the audio. One went into a TNC, and the other one went into MixW. And he was comparing the data decode rates of both programs. And he found that they're roughly the same, with MixW being slightly more sensitive to the packets, which was kind of interesting. So, and then pass prediction software. A lot of people were using actually CalSat 32. I'm not sure what that program is. That's the first time I'd ever heard of it. So, and then Mac Doppler PC, SAT PC32. Pretty standard stuff. Just a slide about CPX Decoder versus GENSO. CPX Decoder is meant as a temporary solution to our problem, and in the future we are definitely going to move over to GENSO when it's ready. Neil's going to do a presentation tomorrow about it, and we get people working at Cal Poly right now getting the GSS working at the Cal Poly station, which we will probably use in the demo tomorrow, which should be pretty interesting to see a station over there using it. And that's all I had. So, thanks. Do you have anybody have any questions? Yeah.
I noticed you're using the old AX25 scheme,
Yep.
which is very old hat now and generally considered to be pretty inefficient.
Yep.
In terms of no FEC in particular. Have you got any thoughts on possibly improving on it?
Yes, we actually are looking at, for our next generation of satellites, moving completely away from FSK. So probably go to BPSK, forward error correction, all that fun stuff. Austin Williams is actually working on a radio replacement. That's going to be his master's thesis this next year or something like that. So we definitely want to. So yes. Yep.
I was just going to ask if anybody in the room has been helping download CP6 data.
Oh yeah, anybody here? No?
I set it up. I don't think I was successful. So.
Oh, okay.
I've heard it a couple of times.
Right, would you just
Yeah.
repeat the questions, please?
Oh yeah, the question was if anybody in the room here had was helping us out with the CPX Data Decoder program, and the answer was no.
One last question. Sorry.
Wooter?
I have two questions from the web chat.
Yeah.
First one is about your modulation, the FSK modulation that you use. The question says, it's not that easy to track and tune the FSK signal, and that will be quite hard for an automated station. Question is, are you planning to change the emission mode, the modulation mode, for the next CP satellites?
Yeah, that was, so the question was, FSK is a little bit hard to decode and use. You have to use sideband cheat and all that stuff. And the question was, are we going to move to something else? And the answer is yes. We actually have an automated program that Justin Foley's been working on, and he's going to present on that at the CubeSat workshop in SmallSat in 2 weeks or whatever. But that's using LabVIEW and stuff like that. But yeah, we definitely want to move away from FSK. So.
And then the second one is, how much power is the satellite producing? I guess it's downlink power that I mean.
Yeah, the question was how much power. RF output's around a watt. So, yeah, I think we're out of time. So, thank you.